I request you please subscribe my channel. Currently you can see I have uploaded more video on many video on Raspberry Pi, Arduino, then Python programming, then some webinar, so that it can grow your career. So if you want to learn something from me, it is free, and you have to just click on this subscribe button, and all the video it is very unique, and you will learn definitely many things from me. I uploaded mostly video on Raspberry Pi, mostly video on IoT, then Arduino. There are different types of project I have explained, and each project having the programming part. So please subscribe my channel, please support me, and please enhance your knowledge by watching my video. Hello friend, in today's session we will learn how we can design and develop a protest simulation of sign language translator project by using the Raspberry Pi and flex sensor. So before start this project explanation, I would like to tell you what you will learn from this video. So I will definitely cover how this project will be developed and the protest software. Also I will cover importance of each and every line from the code, so that you will get idea about complete project. So I request you please watch this complete video, so that you will get idea about each and everything about this project. Okay, before start the project explanation, I would like to tell you what will be the flow of this project. So you can see on the screen we have the 5 sensor. This 5 sensor denote that the 5 finger. So basically this sensor is connected to little finger, then this one is ring finger, then this one is middle finger, then this one is index finger, and this one is thumb finger. So basically there are the 5 flex sensor which are attached to the 5 finger of our human body. So you can see when we say the sign language, then we have the 5, basically it is depend upon our 5 finger activity. So basically if you can see, if a word, if any that person want to say a word, then what he will do, he will just cross all the finger and only one finger will be open, that is thumb finger. Likewise for the b word, all the finger will be open. So likewise there are some movement that we have to track by using this flex sensor. So basically this flex sensor used to track the all the movement, and after this flex sensor track all the movement, then Raspberry Pi detect that movement, then LCD will print that character on this LCD. Then after that Raspberry Pi also speak that character, so it will be the text to speech converter. So this is the complete flow of this project. Now first I will show you the output of this project, so that you will get idea about what you will learn at the end of this video. Then we will cover the hardware connection, and then we will cover the program explanation. So I request you please watch this complete video. Now we will see the practical demonstration. So I will start the project. You can see I will start the project, and now project start working. After some time it will show the welcome message on the LCD, and after that it will show the give the input. So give the input means it start reading the flex sensor input. Now we can see all the 4 finger, you can see except thumb finger, 4 finger are folded, because we have given 1 signal to the 4 sensor. That 1 signal denote that all the 4 finger are crossed, you can see, so that all the 4 finger here cross and only one thumb finger is open, that means a character. So you can see character speak a, and now you can hear also that character continuously. So this music also play that character, whatever the character it will print, that will speak, because all the 4 finger are crossed and only one finger are open, that's why a character will print. Now if you want to change the character, let's say if you want to give the character b, so how you will give, just open all the fingers. So how to open, just give the 0 signal to all the flex sensor. So once I give the 0 signal to all the flex sensor, that means all fingers now open. Now wait for some second, so that it will print the character b. So you can character speak b, and now also it will speak that character. So you can you hear that b character, it already that is sounded b continuously. So that means whatever the input that you have given, based on the input it will print the character. So now let's say assume that first what we will print, we will print L character, and then we will print I. So first L is 3 finger should be closed and 2 finger should be open. So first 3 finger should be closed. So close means we have to give the 1 signal, and last 2 signal sensor should be 0. Now I will run the project once again. So during runtime we will change the signal now. So first welcome message should be print on the LCD. Then you can see character speak L. Now you can also heard the L character. It will print at the back. It will speak at the back end. L continuously. Now what we have to do? We have to change the character runtime to the I. So I means if I want to speak the I character, So
L.
what I need to do, first finger should be open, last finger should be
L.
open, and middle three fingers should be closed. Now you
L.
can see on the screen what I will do. First finger should be
L.
open and last finger should be open, and then middle
L.
finger should be closed. Now you can see on the screen what I signal I have given, 1
L.
0 1 1 1 0, and then it should print the I. So wait for some second,
E.
it will take the input from the sensor. So you can see character speak
I.
I print on the LCD, and it start speaking the character I. So runtime also you can change the signal, you can easily speak the character during runtime. So in this way we
I.
cover the practical demonstration of this project. Now we will see the hardware connection of this project, and then we will see
I.
the programming part of this project. Now before start the hardware connection, it is very important to install this flex sensor library in your Proteus software. So how to install this library in your Proteus software, I will tell you first. So first of all, you have to download my folder. This is sign language translator Proteus folder from my Google Drive link. You can find this Google Drive link in the given description of this video. So once you go to that Google Drive link, you will find this project, and after that you have to download all the files. Then after that you can see there are three files. What you have to do, you have to select these three files and then copy these three files. So once you copy these three files, just go to the C drive, then program 86, then labs and electronics, then Proteus 8, then data, and then library. So once you go here, just copy and paste whatever the file you copy, just paste that file. I have already pasted that file so that it will show me replace the file in the destination. So I don't use this option, but at your case you will not find this one. So easily you can paste your file. So once you paste your file, just close the Proteus software and then again open the Proteus software. You will see the flex sensor library in your Proteus software. Proteus 8 software. Right click on this Proteus software, then run as administrator. Click on yes. So you can see Proteus 8.9 version required to simulating Raspberry Pi project. So once you open this software, click on new project, then give your project name. Let's say Braille. Then give the path. After that, click on next. Then select this create schematic. Click on next. And select the do not create a PCB layout. Click on next. Create a firmware project. Then select the family Raspberry Pi. And click on next and then finish. So once you click on finish, you can see there are two window open, source code and schematic capture. In schematic capture we will design our circuit. So first you need the LCD. So go to the component mode, then type go to the P and type here 16x2. 16x2. Then after that select this LCD, click OK and place that LCD here. So once you place, you have to connect all these pin from that LCD to Raspberry Pi. So first connect RW pin to ground. Go to the terminal mode, then ground and place that ground here and connect that ground to here. After that you require RS pin to connect GPIO4. Then go to a terminal mode, then default and place that pin here. Right click on this pin, rotate anti-clockwise and place that pin in front of the RS pin. Then connect that pin to RS pin. Give double click on this pin and give here name GPIO4. Click OK. Then next party you have to connect enable pin to GPIO17. Then again go to terminal mode, then default, then connect this pin. Right click on this pin, rotate anti-clockwise, place that pin in front of enable pin, then connect that pin here and double click on this pin. Give here name GPIO17. Then next part is we have to connect D4, D5, D6, D7 pin to 18, 27, 22 and 23. So that we have to select 4 pin at a time. 1, 2, 3 and 4. Now select all these pin at a time, rotate anti-clockwise. Then place that pin in front of D4, D5, D6, D4, D5, D6 and D7. Now connect D4 pin to D4, then D5 to D5, D6 to D6 and D7 to D7. After that double click on this pin and give here name GPIO 18. Then next pin D5, double click on this pin give your name GPIO27. Click on this, then click on next pin D6 and give your name GPIO22. Then click on this pin and give your name GPIO23. So successfully we have connected LCD with our Raspberry Pi. Now once you connect the LCD with Raspberry Pi, now next part is you have to connect the flex sensor. So where you find the flex sensor, just go to the component mode, then click on P and type here flex sensor. So once you type flex sensor here, you will find this flex sensor. Then connect that flex sensor, click on OK and paste that flex sensor here. So once you paste that flex sensor here, the next part is you have to connect all the pin of that flex sensor. So first pin is test pin. So go to component mode, then click on P and type here logic state. So once you type logic state, you can select this logic state and click on OK and place that logic state like here, and then connect this like logic state here. The ground pin should be connected to ground. So go to the terminal mode, then click on ground and place that ground here, then connect the ground to this ground. Then output pin, we require one default pin. So go to terminal mode, then click on default and place one default pin here. Right click, rotate anti-clockwise and place here. Then copy this, right click on the default pin. So right click on the default pin, copy to clipboard and paste the default pin here. Then after that connect that default pin to like this. Two default pin you are connected. Then VCC pin should be connected to 5 volt. So double click here and give your name 5 volt. So click on OK. And then after that this default pin we will connect later. But one flex sensor connection is completed. So double click on this flex sensor. Then go to this folder and go to my downloaded folder from my Google Drive link. So let's say this is my downloaded folder. Here you will find the hex file of that flex sensor. So click on this hex file, click on open and click on OK. So in this way we complete the one part of that flex sensor. Now what we have to do, we have to copy all this flex sensor again. So go to this selection mode and copy this flex sensor, select this, right click, copy to clipboard and paste, right click again, paste from the clipboard like this, right click. So we require 5 flex sensor. So right click, paste. 4 is completed, right click, paste. Okay, so in this way we have the 5 flex sensor. Just check each flex sensor having this hex file. So just check all the flex sensor having this hex file. Click on OK. Now one by one we have to provide the Raspberry Pi pin number here. So first pin number you can see 23 is connected to LCD. Then after the 23 we have 24, 25, then GPIO 5, 6, 12. So first flex sensor should be 24. So double click on this output pin and give your name GPIO 24. Then next flex sensor, double click here, give your name GPIO 25. Click on OK. Then third flex sensor should be connected to GPIO 5. Double click on this output pin. You can see double click on this output pin, give your name GPIO 5. Then GPIO 6, next flex sensor, GPIO 6, GPIO 6, click on OK. And then last pin should be connected to GPIO 12. Last pin is connected to, double click here, give your name GPIO 12. Click on OK. So in this way we complete the hardware connection of this project. I hope you understand the hardware connection. Now we will see the program part of this project. Now once we connect all the flex sensor, now only last part is remaining, that we have to connect this 5 volt power supply. So we have to take the common 5 volt power supply first. So just go to this generated mode, click on DC and place that 5 volt power supply here. Then go to default pin and connect the default pin like this. Double click on this default pin and give your name 5 volt. So likewise, then after that you can double click on this power supply and give your voltage as a 5 volt. So likewise you can create the common 5 supply. And then if you want to give the name for this for like supply or any flex sensor, just go to the square box here, click on pin and you can draw the square box like this. Then after that if you want to give the name, just go to the A and go to the pin and connect that pin and give the name here like this. power supply. So likewise you can provide the name to the each and every flex sensor like this. So in this way we complete the hardware connection. I hope you understand the hardware connection. Now we will see the program part. Now we will see the importance of each and every line from the code. So where you write your code, you can write your code at this source code section, and I have already written my code, so I will not write each and every line again, but I will explain you each and every line. So basically first line is import time, then import Raspberry Pi, import time and import OS. So whenever you want to add some delay in your code, then you require this import time library, then import Raspberry Pi.gpi. Basically this library is used to access the GPIO port of Raspberry Pi, then OS, some OS functionality, and then last library is from GTTS, import GTTS. So basically it is this library used to convert the text to speech, but this is the external library. So this is the external library. Now how to install this library I have already explained in my previous video. The video name is this one, Braille keyboard project. In this project I have already explained how to install this library. So if you don't install this library, if you don't follow this project, then you will find the errors in your software. So if you want to avoid that error, you should follow my process that I explain in this project to install the GTTS library. There is one separate chapter to install that library in this video. So please watch that chapter and try to install that library from that video. Okay. Then after that GPIO.set mode, GPIO board. So basically if you want to use Raspberry Pi, then you have to use this line. Then GPIO.set warning to the false. So whenever you require to whenever you use the Raspberry Pi GPIO pins, whenever you run the code, then Raspberry Pi gives you warning that whatever the GPIO pin you have used is already used before. So to avoid that warning, you should use this line. Then next part is depth speak. So basically this is the function which convert the text to speech library. So whatever the text you will provide into data, that will convert into speak, and that will play with welcome.mp3 player. And this welcome.mp3 player nothing but your voice, that is the voice from the laptop. So to convert that character into speak, we use this depth speaks function. Then after that there is some delay. Then you can say LCD RS pin is connected to 7 number, then LCD 11 enable pin is connected to 11. So what is this LCD RS pin? So once you go to the schematic, then you can see here LCD RS pin, that is RS pin, it is connected to GPIO 4, and GPIO 4 is nothing but, you can see on Raspberry Pi, GPIO 4 is nothing but 7 number pin of Raspberry Pi. So that's why here given here LCD RS is connected to 7. Same with the same logic, all the pin number defined here. So you can easily go through one by one pin, and you can identify which pin is connected to which pin. So for example, flex sensor 1 is connected to 11. So if I go to the flex sensor 1, you can see this flex sensor 1 is connected to GPIO 25. Sorry, flex sensor 1 is connected to GPIO 24. And once I go to Raspberry Pi GPIO 24, you can say GPIO 24 is nothing but the 18 number pin. So that's why I have defined here flexion is equal to 18. So likewise with that logic, I have defined all the pins here. Then after that I have to define all the LCD pin as output and all the flex sensor pin as a input. So to define any pin as output and input, I have used this lines. So you can see GPIO.setup, you have to give the number of that pin, and GPIO.in for the input pin, and same number of the pin, and GPIO.out for the output pin. So all the LCD pin as output, because Raspberry Pi send the signal on the LCD, and in terms of the flex sensor, Raspberry Pi take the signal from the flex sensor. That's why all the flex sensor pin as input and all the LCD pin as output. Then after that you can see there is LCD width. So from number 51, line number 51, you can see till from 51 till line number, you can see till here, till line number welcome message, till line number 143. That logic I have already explained in my previous video. You can see this is the video Braille keyboard. So in that video I have already explained all the logic. So if you want to check that logic, please watch that video. And till welcome message, I again repeat, from line this one, from line LCD width till welcome message, till line number this. So if you want to understand till this line, you can watch that video and you can try to understand. I will not explain here again because it will take some again more time. Then after that, give input also already explain into this video also, so please watch that video so that you will get idea. Now very important for only for this project is while one. So while one, after while one logic is changed for this project, that I will again explain here. So you can see while one is nothing but whatever the code you want to continuously run in your project, that comes under the while one. So first 5 line, you can see first 5 line basically used to send the signal from the flex sensor. So gpio.in flex sensor 1 signal, then flex sensor 2 signal, 3 signal, 5 4 signal and 5th. So 5 flex sensor signal will be recorded by the Raspberry Pi and store into this switch 1 data, switch 2 data, switch 3 data, switch 4, switch 5. Now you can see if the switch data is equal to 1, switch 1 data is equal to 1, switch 2 data also 1, switch 3 data also 1 and switch 4 data also 1, but switch 5 data is 0. That means characters A, we have to consider character A, because you can see, as per this image we have considered 5 flex sensor, and when we close the finger that means 1 signal, and when we open the signal that means 0 signal. So whatever the close and open signal we have to consider. For the A character, you can see as per this image, A character first 4 signal are closed and only 5 signal are open. First 4 finger is closed, that means 1 1 1 1 close and 5th is open, that's why A character. Likewise B character, the input is given, and you can see once I give the A character, we have to print that character on the LCD. For that these 2 lines are there, and then we have to speak. So speak, the function is there, and then we have to pass that character speak data as A here. So this 4 line for this first 2 lines, this one to print the data on the LCD, and this line is to speak the character. Same wise we have to speak B, then D, then F, then I, then L, then S. Only this character I have speak right now because you can see all these character are come with the front end, that is front face. So if I want to speak J character, then I have to tilt my this one of hand. You can see I have to tilt my hand. So the tilt logic that I haven't covered in the current project, maybe I will cover in the next coming project, because that requires some additional circuit, that is the accelerometer, but definitely I will cover that part also. But for this only, you can see for this project only I have covered A, B, then D, then A, B, then F, then I, then L, then S. You can see only this logic I have covered in the code. So only that speak character you will find here, and that logic you will find here. So I hope you understand the logic of this program, and I hope you understand the code also this program and hardware connection. Now we will see how to run this project if you want to take my ready-made simulation. Now we will see how to run my ready-made simulation. So if you want my ready-made simulation, just follow this step. You require the Proteus 8.9 software. So right click on this Proteus 8.9, click on run as administrator and click on OK. Then after that go to the open project and then again go to my downloaded folder link. So this is my downloaded folder, and here you will find the Proteus folder project. So open that project, click on open. So once you open the folder project, you will find ready-made Proteus project. Now once you open the project, you will find the ready-made project simulation here. Now what you have to do, you have to check first whether all the flex sensor having the X file or not. So double click on this each and every flex sensor, go to the folder and load the all the X file into each and every flex sensor like this. Double click and load this X file like this. Double click, load this all the X file. So once you load all the X file, your project should be start working. Just click on this run button. So you can see welcome message printed, that means your project is working and you can use this ready-made simulation.